All right, these are notes number 6. They are the second set of notes for this week, and you should already have your paper set up. So these are the last notes we'll be taking for chapter 1. Essential question, what are the theorems from the list and how do I apply them? So as our DMR warm-up, we'll be doing this proof, which has to do with an angle. And so now we'll just start with the notes though. So pause if you needed to copy that. Here are the notes. Okay, so in the book, these are also there. This is section 1-7, so you can look up the pages and look at the theorems in there. But here is the first one we'll go over. And again, this is in the list. My numbering is based off of the list. So these are on PowerSchool, but I like you to have them in your notes so that you can easily refer to them there as well. Our first theorem is this one. It's all right angles are congruent, and I wrote it out if you don't know what that means. But this is the short way you can write it in a proof. You should know angle and congruent, and RT is short for right. A right angle is marked with this little symbol. It's like a box in the corner. So angle 1 and angle 2, they both have that marking. So if angle 1 and angle 2 are right angles, then angle 1 is congruent to angle 2. It's just saying that if they're both right angles, then they're both the same shape of an angle, and that makes sense. And again, that's page 53 if you're looking in the book. Okay, here's the next one. Pause if you ever need to. Congruent supplements theorem. This is number 2 on the list. In the book, it's on a different page. It's on page 51. Okay, so it says basically if this is angle B, and then we have angle A. Do you kind of see how I made them so that if you put them together, it would make a straight line? If you could imagine squishing them together. Those are supplementary. And then angle C is also supplementary with B. So if you kind of just forget about A, look at B and C. Do you see how they would also be supplementary? They would make a straight line, which means that it equals 180. So that's what the angles look like right there. So this is what it says. If angle A is supplementary to angle B and angle C is supplementary to angle B, then angle A is congruent to angle C. So it's saying if angle A is sup to B and C is sup to B, supplementary, then these two are congruent. So I would maybe just put that symbol there just to remind you that those two are congruent. Another really important thing is you need to know that supplementary angles add up to 180. So I'm going to just put that right here again, add up to 180. They make a straight line, a straight angle. And that might be really important. You might want to use a highlighter to emphasize it because you need to know what supplementary and complementary angles are. Okay, they add up to 180. Okay, and then we've got this one, which is really similar. It's the congruent complements theorem. Same exact thing, except we're talking about complementary angles. Okay, so it's on page 53 in the book, but on our list, it's number 3. So I went in order of the list, 1, 2, 3. So like I was saying, this is basically like the same thing, except that these angles are going to add up to 90 degrees. We've got angle 3, and then I tried to make angle 1 look like if you squished them together, it would make a right angle. Same thing here with angle 2. If you forget about angle 1, just look at 3 and 2, and if you squish them together and lined it up, it should make a right angle. Okay, so what it says is if angle 1 is complementary to angle 3, so if 1 and 3 are complementary, which means they add to 90 degrees, and angle 2 is complementary to angle 3, so 2 and 3 are both complementary, then angle 1 is congruent to angle 2. So they are congruent if they're both complementary to the same angle. And again, complementary means it adds up to 90 degrees. And I'll highlight that because that is super important. You need to know that. Okay, so we've got those three theorems, which will be used, but not too much today, but they're in your notes. Make sure you look back at your notes as you need to. And then you don't need to write this down, but we are going to do some work in the book on page 49. All right, so here's my book, open page 49 in volume 1. Remember, you guys can write in this, highlight whatever you need to be doing. This is the proof of the vertical angles theorem, that vertical angles are congruent. So it's important that you look through proofs like this in the book that are worked out. We're moving kind of quicker than the usual pace over proofs. So if you need extra time, make sure you look at your book. So I'm not going to go through it right now, but it is important to see how these different reasons are used. So anyways, we're going to actually just skip and actually solve a problem using the vertical angles theorem. All right, so it's asking what is the value of x, and then I have these two vertical angles. Using the vertical angles theorem, vertical angles are congruent, and then by the definition of congruence, they have equal measure. Definition of congruence. That's an important one that comes up a lot later in proofs. So I'll just write that vertical angles are congruent. Vertical angles are congruent, and the definition of congruence. I can just set them equal and solve, since they are vertical angles. The ones that are across are equal. I would subtract 2x over to that side and get x equals 40. So I have x, then I need to substitute x to find the actual measure of the angles. It doesn't say to do that, but I want you guys to see how to do that. So for this top angle, it would be 3 times x. So 3 times 40, 120. The other angle across should be the same, but let's just check by plugging in 2 times 40 plus 40, just to make sure. 80 plus 40 equals 120. So it does work. They should come out to be the same. Okay, so if I know that those two angles are 120, I can also find these angles, the other vertical angles. Remember that this is a line and that these two angles are supplementary. So I would just have to do 180 minus 120, and that would be 60 degrees. Same thing here, and plus it's a vertical angle, so that one's also 60 degrees. Okay, and then I'm not going to do this next one, but if you want to, you can try it. You would start by setting these two equal, solve for x, then you would find that missing angle, just like we did that one. All right, so what I want to go to, though, is on the next page. I guess I should circle my answer before we move on. Okay, on the next page, let's look at this proof. Remember, I was saying we don't have that much time, but proofs are important. We do need to know how to do these. So I made a little note to myself. After note 6, we are doing this. Okay, so when you look at a proof, you want to really look at the diagram and kind of plan out some sort of a plan. Look at your given and what are you trying to prove, and always think, can I prove that? You can kind of just think through it. Can you get to it? Luckily, this proof is, a lot of it is done for us. We just have to fill in the blanks. Eventually you will have proofs that you have to fill in completely. So those are a lot more difficult. So anyways, we are given that angle 1 is congruent to angle 3. I can mark it with the arc like that. What we are trying to prove, I'll use a different color, is that angle 6 is congruent to angle 4. So I would look and try to find 6 and 4. So I'll just mark it a little bit differently so that I know. So we're going to try to go from this one fact to being able to prove this. And again, a lot of the hints are there. So one thing that I notice is it's starting with angle 1 is congruent to angle 3. That's given. And then it says angle 3 is congruent to angle 6. So look at 3 and 6. Do you notice that they're vertical angles? And like if I highlight, I think it'll make it a little more clear. Look at how they are formed with two straight lines. So 3 and 6 are vertical angles. So vertical angles are congruent is the reason for this one. Vertical angles are congruent. It's the vertical angles theorem, but that's the short way to write it. Okay, so I can see my next reason, the transitive property of congruence. So if you look up the transitive property of congruence, like maybe on PowerSchool or in the notes, if we did it there, you would see it's kind of like two angles are congruent and two angles are congruent, then the other angles are congruent. So what I would do is I would look at what do I have before, and then looking at here, I'm seeing, oh, if angle 3 is also congruent to angle 6, let me mark it with the pen because those are congruent. They're vertical angles. Well, then 1 and 3 are also congruent, so I'm going to mark it there. Then angle 1 is congruent to angle 6. Since angle 1 and 3 are congruent, and then 3 is congruent to 6, I can go from 1 to 6 and say that those must also be congruent, which means they're the same shape, the same size and shape. Okay, now the next one says that angle 1 is congruent to angle 4. Let's look at the diagram. 1 and 4. I already have them marked congruent from all the marks I did, but what I'm noticing about 1 and 4, let me highlight with a different color. They are also vertical angles. Anytime you see that X and then angles across from each other, that's vertical angles. So I can write that reason again. Remember, you can write the same reason if you use it twice. Vertical angles are congruent for 1 and 4. And it's kind of like what we just did again. It's almost like a pattern. We did angle 1 is congruent to angle 6. Angle 1 is congruent to angle 4. So then wouldn't angle 6 be congruent to angle 4? So it's the transitive property again. Transitive property of, we can shorten it and just write the congruent symbol. Okay, so that is that proof. Look through it again, just kind of make some sense of it. This is a good practice though to see transitive property of congruence. We're saying that if angle 1 is congruent to 6 and angle 1 is also congruent to angle 4, then 6 and 4 must be congruent. That's transitive property. It's almost like substitution, kind of, but it takes two angles and then two angles and then two more angles. That's one way to notice that it's not substitution. Okay, so from the notes, this kind of just shows this is where the theorems are. I'm going to go to the chapter review and we're going to just do a couple more problems. So this is page 53. I want to see if you guys can get the measures of angle 1, 2, and 3 given this information. So pause it and try it. And now I'm going to help you. So pause it if you haven't tried it yet. It doesn't really matter where you start because I'm seeing a lot of vertical angles. Look at that. I see vertical angles for 1. Across from 1 is a box, but that means 90 degrees. Also notice that this is a straight line. These 3 should add up to 180. 90 plus 50 plus 40 is 180. So I know that that is correct. That is 90 degrees. So measure of angle 1 equals 90 degrees because of the vertical angle that's congruent. And then if I do angle 2, it's like this. And so I can see across from angle 2 is 50. Vertical angles are congruent, so measure of angle 2 equals 50 degrees. And then for angle 3 is right here and here. So I can see vertical angles are congruent. Measure of angle 3 is 40 degrees. Okay, let me see. Let's do maybe one more. Okay, so there's that one. And then turn the page. We can do this one also. It involves solving a little bit, so that's always good. What is the value of x? And those are our choices. So these are vertical angles because it's formed from two straight lines. 6x plus 16 equals 136. And then you just solve. So first I subtract 16 to both sides. 6x equals 120. And then divide by 6. X equals 20. So what is the value of x? It is 20. Make sure you're reading the right thing. I don't have to plug it in and solve. I already know that that angle would be 136. If I plug in 20, that should work out to be 136. But x is 20. It's that one. Okay, one more thing I just wanted to show you guys is if you turn, this was the very last section of chapter 1. So there is a chapter review. This starts on page 58. We skipped a lot of these because of we didn't have a lot of time. So we skipped like basically all of these. If you want to look through it, you can, but you won't be like tested on it. But it is interesting things that normally we would cover in the school year. Even 1-5, normally, we would cover that. But there is a review of 1-6, which we've done. See if you can do that proof and answer number 29 and 30. See if you can do those. And then on this one, 1-7, this is this section's review. See if you can do this one. You don't have to do a paragraph proof so much, but looking at this, let's see if you can solve for y. I'm noticing those are vertical angles, so you can find y by setting them equal. Then you can find the measure of the 3 different angles. And then there's just a little bit more. You can try to figure out 35. Okay, so that's it. Finish up the notes and come back to class because we are going to do more in class.